Okay, so in this graph, we want to know the percentage that are less than 70. So for less than 70, let's see, in the 40 to 50, I have one observation. 50 to 60, I have two observations, and then four observations in the 60 to 70. So that's the last of the ones that are less than 70. So let's go ahead and get the rest of them. 70 to 80, we have five, and then two, and then one. So our total is 15. And of those, we have 1, 3, 7 that are less than 70. So 7 divided by 15 is 0.467, or about 0.47. So that'll be C. Okay, so moving down here, go ahead and move this out of the way. Conducting an experiment to ascertain the effect of deep sleep on mental disorders. So we have an explanatory variable and a response variable. The response variable is the thing we're trying to predict or trying to find something out about, and the explanatory is what we're using to explain that. So in this case, deep sleep would be or deep sleep therapy would be the explanatory variable, and mental disorders would be the response variable. That's what we're trying to find out about. And then to test the effect of music on productivity, workers are observed. Be careful about this. I'm going to just go ahead and tell you this is not an observational study. For for 1 month, background music is played. For another, no music is played. The reason this is an experiment and not an observational study is that something was manipulated. In this case, the variable being manipulated, the explanatory variable, is whether or not the music was played. So we didn't just observe things, we did something to, or in experimental language, we manipulated an experimental variable, in this case, whether or not music was played. And since we have so, and take a look at this, and what I think is that there are two possible correct answers to this one. And here's why I say that. If these are the same exact workers that are observed both times, so we could have worker number 1, number 2, number 3, number 4, number 5, and so on. And if we then get in month 1 their performance measure, and in month 2, in other words, 1 was when there was they had background music, and number 2 is when they didn't. And then we had some productivity levels, and it went like that. This is a matched pairs. It's actually even a subset of that, a repeated measures a kind of test. And so what we're really interested in here is the difference. So the first worker went -5, and the next one 11. So that's one possible answer to this. And the key is that right here we just have one sample, and we're getting two measures on each. So we're looking at the same exact workers in month 1 and in month 2. The other possibility would be that we have a random sample of workers that we randomly selected some workers here. Let's say worker 1, 2, 3, 4, 5 in the first month, and then in the second month we had a different set of workers. These aren't the same people, so now it would be two separate groups, and that would be a completely randomized exam. So on this one, I'm going to have to accept B or D. I don't think that this is made completely clear in the wording of that problem. Sometimes it happens. Okay, so some more of these here. We have a normal population with a population mean of 75, and I'll go ahead and tell you, I am going to ask about the empirical rule, but it won't be 5 or 6 questions like it is on this review. Probably 2 or 3, though. So we have a mean of 75 and a standard deviation of 5, and we want to know between 85 and 80 and 85. 80 and 85. So we're looking for this area. Remember, everything has to be done with respect to the mean. So I can't get that area directly, but I can get this area, and I can get this area. I'll call this area A and this area B. So for area A, 85 to 75, that's 2 standard deviations. And remember, plus or minus 2 standard deviations goes with 95. And if we just go in one direction, it'll be 95 divided by 2 is equal to 0.475. So area A is 0.475. Area B, from 80 to 75, is 1 standard deviation. And if you go 1 standard deviation in one direction, that's going to be half of 68, or 0.34. So this part is 0.34. So the final answer is going to be 475 minus 0.34, which is 0.135, and that's A. And let's see, the next one says the 97.5th percentile. So let me redraw this all out. We have a mean of 75 and a standard deviation of 5. Well, we're looking for the 97.5th, 0.975 or 97.5th percentile. We're looking for the score, or the x that's at that point. Well, from the mean down is 0.5. That leaves 475 in here. And you should recognize by now that that is half of 95. That is, that distance is 2 standard deviations. And it's above the mean. So just go the mean plus 2 standard deviations, or 75, plus 2 times, that's a 5 there, is equal to 85. And so that'll be your answer on that one. The next question, when we're having a standard deviation contest, which of the following has the smallest possible standard deviation? And that'll have to be this one, because it's going to be 0. All of the points are exactly equal, and they're all equal to the mean. So when we get a deviation, it's going to be 0 in this case.